This is our first lecture on section 4.3. Our objective this time around are what is a linear equation in one variable, what are the solution sets, how to solve, and what satisfying a linear equation in one variable looks like. I will discuss the identity and inverse properties for both addition and multiplication, although Leemann's book does not. Leemann will discuss the three roles of a variable, which I will not. We will both talk about equivalent equations. We will be solving linear equations in one variable using both the addition and multiplication properties. And then we will be graphing to show how a linear equation in one variable can be solved using our graphing methods. So without further ado, let's get into what a linear equation in one variable looks like. We have a linear equation in one variable looking like sum m times sum x plus sum b is equal to 0. Now, Leemann uses m and b so that it kind of relates back to the last chapters that we've talked about linear equations in two variables, the slope and the y-intercept being our m and b before. Those are not the case in this particular application. They're just going to be real numbers. They're not going to have that special meaning attached to them. But when we relate it to our graphing, then this is a one-to-one correspondence and there's no confusion. So we have our m not being equal to 0 because of course we can't get rid of the variable and x is our variable. Now our job is going to be to solve this linear equation in one variable by getting it to look like x is equal to some number. Now x equals some number will be an equivalent equation to this original mx plus b is equal to 0 equation. And we're going to make that happen through some of those properties that I was talking about, identity, inverse, and addition property at first, and then identity and inverse and multiplication property second. So our job is to first of all find out what does the solution look like, how do we verify that it satisfies our equation, and then how do we actually get that solution or that value that satisfies the equation. So next, let's talk about solving a linear equation in one variable. Finding a solution is finding an x value that will make a true statement. So finding out if a solution satisfies an equation, some of us call that a check. And that's just substituting the value that we find, x to b, back into the original equation and seeing if it makes a true statement in the original problem. If it does, then it's verified that it does satisfy. Just like we saw back in linear equations in two variables, except for now we only have the one variable to plug in for. All right, now we have just a quick example of how we can check an equation for a solution. So is x equal to a solution of x plus 9 equals negative 11? So to check this, to verify whether it's a solution, we're going to plug it in like that, and then we say this, and we're asking, is that true that it equals negative 11? And 2 plus 9 is 11, but that doesn't equal negative 11. So as it turns out, know that 2 is not a solution. So 2 is not a solution. So that is that verified. Now the other one we can do is we can say, okay, is x equal to negative 20 a solution? So we have negative 20 and then plus and then 9, and we're questioning, does that equal negative 11? And 20 minus 9 is 11, and it is negative, and negative 11 does equal negative 11. So this is a solution. And that is the verifying of whether a point is a solution or not. So x minus 20 is a solution. Now our next task is going to be to find those solutions. How do we create an equivalent equation to verify or to find the solution? So we have to get a few properties, and the properties I'm going to talk about are these three properties: the inverse property, the identity property of addition, and then the addition property of equality. And again, Leemann is only going to discuss the addition property of equality, but I need all of them to make my math magic, and I'll tell you more about that in the next lecture.